So we know that pressure is defined as the force per unit area. One thing that came up early on is whether or not the pressure could be changed by pushing on a fluid. If you think about how your heart works, for example, your blood pressure increases when your heart pushes on the blood within your blood vessels. The particles of the blood are free to move about, and since they are in an enclosed system, those particles transmit the pressure to all parts of the fluid and the walls of that container. This is actually the idea behind Pascal's principle. It simply says a change in pressure applied to an enclosed fluid is transmitted undiminished to all portions of the fluid and the walls of its container. This just means that if we increase the pressure within the fluid, then the pressure increases everywhere. Take a balloon. If you squeeze the balloon, the pressure increases everywhere in the balloon. The implication here is that the total pressure in a fluid is the sum of the pressures from all the different sources. As you might imagine, we find this relationship to be very useful. If we take an open tube and add some liquid to it, you probably know that pressures like to equal themselves out. And so the levels on either side of that open tube are going to even out. If you increase the pressure on the right, then the water level on the right will move down, and in turn, the water level on the left will move up. If you decrease the pressure on the right, then the water level on the right will move up, and in turn, the water level on the left will move down. Pascal's principle plays a huge part in one of the most important technological advances ever, the field known as hydraulics. Hydraulics simply refers to an enclosed fluid system that is used to exert a force. In our diagram, we have a cylinder on one side that is connected to a cylinder via some tube in between. The cylinder on the left is smaller in area than the cylinder on the right. Each cylinder is capped with a piston that moves when the pressure changes. So if we push down on the piston on the left, the piston on the right moves up. This happens because the fluid is incompressible, and so the force on the left is transmitted throughout the fluid all the way over to the second piston. Pascal's principle tells us that if the pressure on the left side is equal to the pressure on the right side. If this is true, then the force applied on the left, divided by the area of the cylinder on the left, is equal to the force applied on the right, divided by the area of the cylinder on the right. In hydraulics, we are a lot of times concerned with the force output of our system. So we can always rearrange to solve for that force being applied by the piston on the right. If we ignore friction and the pistons are positioned in the same vertical height, this makes hydraulic systems analogous to a mechanical lever. We can apply a small force downward on the small piston, and since that pressure transmits undiminished to the piston on the right with a larger area, the resulting upward force of the larger piston will be larger. The advantage of a hydraulic system over a mechanical lever is that the fluid can be used to exert a force in all directions. This allows us to create a system that has all different kinds of shapes and curves and still be able to apply the needed force. A common example of this is the hydraulic brake system in most vehicles. In this example, the driver is applying a 100 Newton force to the brake pedal. The pedal pushes on the fluid in the small cylinder, called the master cylinder, which in turn pushes on the 4 slave cylinders, which are larger in diameter, in the brake system. As a result, the slave cylinders apply a larger force to the fluid inside the brakes.